So the last part of chapter 8 is looking at solids. And so a solid is now a three-dimensional object. So instead of looking at something flat on the paper like a circle, now we have an object like a cardboard box or a metal soup can. So we have a three-dimensional object. And so our object is going to have a length, a width, and a height. Okay, if it's a cylinder, like this example here, you would have a radius, or perhaps you'd be given a diameter. So the total surface area for any of these objects, what would that mean? Well, we're still talking about area, so that's a two-dimensional measurement, but we're talking about the total surface area around the entire object. So this was kind of, it would be like, how much wrapping paper do you need to cover the entire object? Or if you were looking at a soup can, how much tin would be required to make that soup can? And there's a bunch of formulas for total surface area, that would be better. For total surface area, these are found in your geometric formula sheets, and they're listed here. So for a rectangular solid, it would be 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height, okay? Or you can use this form here if you like. For a cube, it would be 6 times the side length squared. Okay, so S here is side length. And so on. So the formulas are given here for rectangular, solid, cube, cylinder, and sphere, and those are also given in your formula sheet. So that's total surface area. Think of wrapping paper. Volume is the amount of space that's inside the object. So for example, that rectangular solid, imagine it was a fish tank. How much water would it take to fill that fish tank? Or you can even think of how much air would it be occupying the space of that fish tank. And so there's also formulas developed for volume for all these different shapes here. So let's start with what we call a rectangular solid. So our cardboard box or fish tank. And we're asked to find the total surface area and volume of this rectangular solid. So let's start with total surface area. Okay, total surface area. So if we look on our formula sheet at rectangular solids, total surface area is 2 times L times W, length times width, plus 2 times length times height, plus 2 times width times height. Sometimes people use capitals, sometimes people use lowercase, use whichever you like. Okay, so we've got 2 times length is 18.2. And maybe I'm just going to use brackets for multiplication, so there's not so many dots in here. And then our width is 6.3. So we're basically just plugging in all of our variables, all of these letters we know the values for. So now we've got 2 times L, L was 18.2, times H, which was 9.1, and then plus 2 times W was 6.3, and height was 9.1. Okay, so let's calculate this. So I'm going to do each one individually. You can do this all in one step if you prefer. But for that first number, I get 42.7. And then we've got plus so here I get 45.5. And then the last one, 114.66. So when we add all those up together, and once you get more comfortable with your calculator, you might feel more comfortable doing this all in one step. I get 202.86. And we were asked to round to the nearest tenth. So that's going to give me 202.9. Now, what are our units here? This is area. So with area, our units are squared. So this would be centimeters squared. All right, let's do volume now. So if we're trying to figure out the amount of space this object occupies, we're looking at volume. And volume of a rectangular solid, if you look on your formula sheet, you'll see its length times width times height. So our length is 18.2. Our width is 6.3. And our height is 9.1. And so what does that give us? So I get 1,043 and 406 thousandths. And we're rounding to the nearest tenth. So that's 1,043.4. And what are our units here? Well, anytime we're dealing with volume, we're going to have centimeters cubed. And that kind of makes sense because we're multiplying length times width times height. So we're multiplying centimeters by centimeters by centimeters, which gives us the centimeters cubed.